Elliptic curve cryptography and quantum cryptography are two more encryption technologies, but these are less commonly used. The foundation of asymmetric cryptography is based on the difficulty of solving complex math problems. For example, the RSA algorithm is based on the math of solving complex large prime numbers. A prime number is a number that is divisible by itself and 1. Let's say, for example, that I told you I was going to multiply two prime numbers and give you the answer. For instance, 15 would be the answer of the multiplication of two prime numbers, and I told you to tell me what those two numbers are. You would be able to easily tell me that those two numbers are 3 and 5, as 3 and 5 are both prime numbers that multiply to 15. Similarly, if I told you that I multiplied two numbers to get 21, you would tell me those two prime numbers are 7 and 3, because those are the two numbers that are prime and multiply to 21. However, if I gave you a number like 33,878,633 and asked you to provide me the two prime numbers that multiply to that, you would probably have a little bit of challenge. This is what a cryptographic algorithm like RSA is founded upon, and the challenge of prime factorization for very large numbers is what makes it so successful. Now, if an efficient method of solving prime factorization was discovered, modern cryptography utilizing prime factorization as we know it would be rendered completely useless. Enter into the equation elliptic curve cryptography. Elliptic curve cryptography does not depend on prime factorization. Instead, it uses the elliptic curve discrete logarithmic problem. Elliptic curve cryptography is a public encryption technique based on elliptic curve theory that can be used to create faster, smaller, and more efficient cryptographic keys. Elliptic curve cryptography generates keys through the properties of the elliptic curve equation instead of the traditional method of generation as the product of very large prime numbers. The technology can be used in conjunction with most public key encryption methods such as RSA and Diffie-Hellman. According to some researchers, ECC can yield a level of security with a 164-bit key that other systems require a 1024-bit key to achieve. Because ECC helps to establish equivalent security with lower computing power and battery resource usage, it is becoming widely used for mobile applications. The equation of an elliptic curve is given as y squared equals x cubed plus ax plus b. And the graph to the right is a graphical representation of this equation. In recent years, quantum computing has become very popular. Quantum computing utilizes quantum mechanics to perform computing tasks. Quantum computing is still in the early stages and is heavily theory-based, but it is significant because advances in quantum computing may be able to defeat cryptographic algorithms that depend on factoring large prime numbers. It's also important to note that the elliptic curve cryptography cannot protect against quantum attacks, and elliptic curve cryptography is even more vulnerable to quantum attacks compared to prime factorization. On the positive, however, quantum computing may provide superior algorithms.